Hey guys, Mr. Backerberg here. In this video, we're going to look at domain and range. As we're looking at the domain of a function, the domain is the complete set of possible values for the independent variable. Typically, we call these your input values, so these are the numbers that you're plugging into your function. If we've got an equation written in terms of x and y, then your domain deals with the x values. When we're talking about the range of the function, this is the complete set of possible values for the dependent variable, and we would call these your output values. And again, if we're talking about an equation in terms of x and y, these would be your y values. So your domain deals with the x values, the numbers that you're plugging into your function, and your range deals with your y values or your output values. So those would be the answers that you get whenever you plug in a specific number. As we're taking a look at this first example, we're going to be identifying the domain and range given the function y equals x. So as we're talking about the domain, we want to think about the numbers that are safe to plug in for the x variable. And there's a couple of issues that we could run into, but we don't have any problems with this one. So as far as the domain of this function, it's safe to plug in any real number that we want. Now the symbol for all real numbers is an R with a double vertical line on the side. Now we could also write this out as an inequality. Because we're able to plug in any real number, then we would say that the domain would go from negative infinity up to positive infinity. But then there's another way that this can be represented as well, and that's in interval notation. So it's similar to what's happening with the inequality. We're going from negative infinity up to positive infinity, but we're going to write it out, and it's going to look sort of like an ordered pair. But because we're not including the negative infinity, because negative infinity is not really a number, we put a parenthesis around that. So we're going from negative infinity up to positive infinity, and that gets a parenthesis around it as well, because we're not actually including infinity. If we were including the specific end value, then we would put a square bracket around it, but infinities never get included. Now, as far as the range, the thing about this function, it says that your x's and your y's are always equal to each other. So because the domain was all real numbers, your range is also going to be all real numbers. And again, we can represent that in the other ways as well. So as an inequality, we would say y values between negative infinity and positive infinity, or we can also write this out in interval notation as well. So going from negative infinity up to positive infinity, again, using parentheses around that because we're not including infinity. Something similar happening here in example 2, but I've changed the function just a little bit. So now we're looking at the equation y equals x squared. And again, we're going to look at identifying the domain and the range of this function. A lot like we saw in the previous one, with this, we're not running into any mathematical issues. So as far as the domain, it's going to be safe for us to plug in any real number that we want. And again, we can represent that in the other ways as well. So x values from negative infinity to positive infinity, or if we were to write that out in interval notation, going from negative infinity to positive infinity. Now, when we get to the range, this is going to be a little bit different because we're not going to get all real numbers on this one. When you square something, regardless of whether it's positive or negative, you always get a positive answer. So as far as representing this, it's going to be most helpful for us to write it out in either inequality form or in that interval notation. So because we're always getting positive real numbers here, we could say that we're going to have y values that are greater than or equal to 0. And then for that interval notation, the smallest possible value is 0, but we are including 0. It is possible to have exactly 0 as your answer, so that's going to get a square bracket around it to include it. But this is going to run up to positive infinity because there's no limit as to how high these numbers are going to get. And infinity always gets a parenthesis around it when we're using that interval notation. In this example, we've got the function y equals the square root of x, and we're going to be doing the same thing, identifying the domain and the range. Now up to this point, we haven't run into any issues with the domain, but as we're looking at this one, thinking about numbers that are safe for us to plug in for that x value, We want to remember that we can't safely square root negative numbers and get a real number answer back. So as far as numbers that are safe to plug in here for x, we're going to want x values that are greater than or equal to 0. In interval notation, that would be the interval from 0 up to infinity, including the 0 but not including infinity. And as far as the range is going to be very similar. When you plug in a number and square root it, you're always going to get a positive answer. So the range is going to be y values that are greater than or equal to 0, or in interval notation, that would go from 0 up to infinity as well. Last example here, now we've got ourselves a fraction that we're dealing with. So we've got the equation y equals 1 over x. And again, we're going to look at identifying the domain and the range of this function. As we're looking at this one with the fraction having x on the bottom, we know that we are never allowed to divide by 0. So it would not be safe for x to be 0 in this case. So we could just say that the domain is x values that don't include 0. Now, if we were to write that out using an inequality, we would actually have to write out two inequalities. So this could be x values that are less than 0, but not including 0, and also x values that are greater than 0, but again, not including 0. Writing this out in interval notation, we would go from negative infinity to 0, but we can't include 0 because it's not safe to actually plug in 0, and negative infinity never gets included. But there's another interval as well that would go from 0, again not included, up to positive infinity, and it's the union of these two intervals. Very similar things are going to happen here for the range. As far as the range goes, we're going to end up getting y values not including 0. And we can write that out in the other forms as well. As far as inequalities go, we would say y values that are less than 0 and also y values that are greater than 0, but we're not including 0 in either of those inequalities. And similarly for the interval notation, we'd go from negative infinity to 0, but not including 0, and also from 0 up to infinity. That's going to be it for this video. Thanks for watching.